Okay, there we go. All right. So yes, 1A.7 part C. And so when you were told to work this problem, I told you to go ahead and put in zeros, 1, 2, 3, 4s, and 5s. And then after we did that, we then went to Desmos to analyze the graph. So when you're using Desmos, that's pretty. Okay, when you're utilizing Desmos, remember we add table, nothing is different. And at this point, you should be able to do this in your sleep, right? If you haven't caught on to how to use Desmos, that means every time that I've been telling you to practice it with the class, you've been refusing to practice it. You've been refusing to try. So now you're going to be in the position where you have no clue how to use your technology properly, which is not good. So if you are still struggling and you cannot remember the steps of how to input your information into Desmos, I'm going to strongly encourage you to go home, watch videos, and if you still are stuck, come back and ask questions. But if you do not practice, come your test on Wednesday, you're going to be struggling. And because it's a big part of the test is being able to still create regression models, read regression models, go over what a residual is and whatnot. And so if you can't do those things, that's a big red flag. Okay, so then we put everything in. Remember, once I put everything in, it's just a matter of me it's just a matter of me adjusting my window. Thanks to all the updates, it adjusts automatically for me. I can look at this window, say, okay, I think it's a curve because it has a little bit of a curve to it to double check. I can now come up here to the regression model, click on my regression model, and it says, okay, here's the line. I can look at the line and see that it's not the world's greatest fit. I also can look at my correlation coefficient. I also can turn on the residuals and look at my residuals and see that they're not evenly scattered. They're kind of mainly below. They go up and down. And so there's a lot of things that tell me that even though I thought it may have been linear, it's not linear. I can go to quadratic. When I go to quadratic, notice that my R squared, my correlation coefficient is even higher than linear, right? So because of that higher correlation, that lets me know that it's a better model. I also can look at the residual plot and look at the residual plot. I can kind of see that it's not really making, it's a little bit scattered. It's a little more scattered. Quadratic is not the most perfect one, but it is a pretty high correlation coefficient, correct? And so that's what I get from this. I also get what my equation is. So I get that my equation is given to me to save your equation so that you can be able to analyze. That's where we press that little, I call it the little notebook there. So we press the little notebook. The reason why we want to be able to analyze it, grab it from the notebook is because that's the only way you're going to be able to create a table. Does that make sense? So now I have my table. Now I have my function. And I have all these tools that I can use to analyze. So in your assignment, what it asked you to do was using the graphing utility, only looking at the scatter plot. What do you notice? Well, we notice that it's increasing. I think someone said maybe linear, but we just checked linear. It was not. But all part A was your prediction of what you think could happen or what is happening. On part B, it says, what is your regression equation? The regression equation is given to you. It tells you this is your regression equation. You wouldn't have to type it all out. You would round it to the nearest three or four decimal places, and that would be your answer, right? I'm just on a computer, so it was just easy for me to copy and paste, right? And then it said in 2025, what is the predicted wind power capacity? So because it says 2025, I have to remember that my initial table started at 2010, right? And because my initial table started at 2010, I'm not actually looking at 2025. I'm looking at 2025 minus 2010, which is why we would go look and see when x equals 15. Okay. So we talked about once you have your x value, you can then go to your table. And on your table, you can input whatever you need. So if I need x equals 15, I can change this first value into 15. And then it tells me that this is the value that at 2025, roughly it should be. Okay, so now I have a value. Then we went back here and it says, what is a reasonable domain? My reasonable domain, I'm sorry, let me finish the thought here. In 2025, which is x equals 15, the predicted wind power capacity would be 175 and 182,000 megawatts. Okay. And that is me answering the question directly pertaining to the problem that was given to me. All right. Next, it says, what is the reasonable contextual domain for this scenario? Is it reasonable to assume the regression equation would yield accurate predictions far into the future? So this part is like asking you, what is the domain of the data you're given, right? Well, the domain of the data I'm given is from 2010 to 2020, right? And then when it says, when we're talking about contextual, we're asking, how far do you think this will keep going? Like, how many years can I predict? Is it going to always just keep going up and up and up and up? Or is there going to be a limit to the length of not the length, to the amount of watts? And the realistic answer is yes, there's going to eventually be a stopping point, right? This isn't an infinite situation, and that's all you did there. So something to that reasoning is all you have to write in there. Then next, we went to the weights of the most fish species can be estimated fairly accurately with their lengths because there is a predictable relationship between the length of a fish in inches and the weight of the fish in pounds. Jasmine is an avid fisher of yellowfin tuna. Unfortunately, the length to weight chart she uses to estimate the weight of the yellowfin tuna she catches got smudged in a few places. Okay. So for this problem is what I left you guys doing at the end of class. You all remember doing that? Your job is to find the regression model and fill in the blanks. So for the ones who did it, thank you. For the ones who did not, I guess here we go. And hopefully you do it this time. So on here, the first thing we're going to do, it says use a graphing utility to create a scatter plot of this data. Based on the scatter plot and the table of values, do you think the quadratic function could be an appropriate model for this data? Why or why not? So I'm going to go ahead and put in the values that I have. Notice that I've highlighted my blanks, right? My blanks are highlighted, and the reason why they're highlighted is because that's to make sure I don't include those. Does that make sense? And so it's just my little reminder, something's missing. Remember on Desmos to start over in the graphing mode, you're just going to hit refresh and it's going to clear your data out. Now I'm going to add a new table, and in this new table, I'm going to be honest with y'all, I'm going to go ahead and put in those initial values, and I'm going to go back and delete them out just because I want to use the feature of it automatically typing things in for me. So by that I mean I'm going to type 25, I'm going to type 27, and it's going to realize that I'm counting by the odd numbers all the way up to 49. I then am going to go back in and delete out. I don't need 27. I don't need 35. And I don't need 39 because it's missing out of my data. And I don't need 45. So in my mind, it just was a lot faster for me to go ahead and let the calculator do its thing. And now I'm going to go in and put the Y values in. So 25 was at 11, 29 was at 17, 31 was at 20, 33 was at 25, 37 was at 35, 41 was at 48. And I repeat again, if you're not trying and following along, you're ultimately going to not do well on your test when it comes to asking you about analyzing scatter plots, residuals, and regression models. 55, 73, and 85. Okay, now that I have all my data in again, I'm going to adjust my window. Remember, Desmos has made it even easier for you to adjust your window by clicking this little guy right here. So we adjust our window, and I'm now in the blank. You're supposed to be writing, do you think a quadratic function can be an appropriate model for this data? Why or why not? That is your personal opinion. So on your paper, write it in. Do you think it's a good model or not? Okay. Now that you made your prediction, now it says we're going to actually go ahead and determine the quadratic regression equation for the data. Then analyze the residual plot. Does the residual plot suggest the quadratic model is appropriate? Why or why not? So when I go over here, I'm going to add my regression. I'm not doing linear. I'm switching to Quadratic. Quadratic is at a 0.999991. Pretty darn good. If you look right here at our residual plot, notice how our residual values are almost on the positive x-axis, right? They're almost equally lined up on that positive x-axis, which lets us know that this is a really great model for a quadratic quadratic regression. Now that I know that it's a good model, it says, what did you get? And why is it a good model? So in your own words, what I just said and what you see, you're going to put down. Why is it a good model? Based on looking at the residual plot. And then here's your equation. So I'm going to write in my equation. If at any point you are stuck or you need me to help you through a step, please do not hesitate to let me know. Remember, if I could read minds, I would be rich. But I can't read minds, so you have to let me know when you need my help. All right, did we finish writing our reason down? Again, if you need help, I'm somewhat paid to help you. All right, so moving on to the next part, it said use the quadratic regression you determined in part B to estimate the missing values in Jasmine's chart. So we got to find all of her missing values, right? So I'm going to go back to Jasmine's chart. I forgot to highlight one of them. And no one was like, Miss Jones, you forgot a box. Thanks for helping me. Okay. So we're going to first find her missing Y values because that just means we're putting it in a table, right? So we're missing a Y value here and we're missing a Y value here, correct? Because we're missing a Y value, that means we're going to plug in the X's that we do know to find their missing Y values. So we know 27 is our X and 45 is our other X. So when I go to the table, I'm going to come over here. So I've already copied my equation down. I'm going to click on the tool, open the table, and I need to find the value of 27. And I need to find the value of what? 45, right? Not 39 yet. So these are my two missing values that I can go ahead and put in those places. Yes. Do which part again? Which, the typing or making the table? You got to be a little more specific with your words. The table. So here's like from this part or from for this. I hit the gear. The same thing we've been doing for 2.5 weeks. Okay. So we got to follow along, guys, and ask the questions initially because therefore you will learn and it'll settle in. Okay. And then you just change the values. Your tables can be manipulated. Okay. So yes, it's going to give you those 5 values, but you can put in whatever you want or need for your problem. Does that make sense? Yes. Okay. So we found our missing values. So for 27, we know that it's approximately 13 33.7. And for 45, we know it's approximately 64.6. Make sense? Okay, so I'm going to go ahead and write those down. You guys may have to remind me when I get to the page because I forgot already. All right, so for 27, what did I have? 13 point what? And then for 45, what was it? 64? 64.6. Okay. All right. So that's what happens when I'm given the X, right? The other two, we're not given the X, we're given the what? The Y values. Do we see that? So for the other two, we're given the Y values. Here we go. So next part is solving for the X. So notice how we're missing our X value, right? When we're missing our X value, we can't just go to the table and um, it was an accident. You can't just go to the table. So we're going to actually use y equals that value. So notice that we're given our y values. So we're going to create a intersection, a point of intersection on our graph so we can see where y equals that value. So we're looking for y equals 30 and we're looking for y equals 41. Does that make sense? Okay. So we're going to go back to our graph and we're going to come over here and we're going to type in the y value we want. We want y equals 30. Okay. So when I type in y equals 30, notice that it gives me two possible answers. One here at 5.26 and then one here at 33.32. I'm at 35. I can see it's a weird angle. And y'all are just going, still, just let me say these things. What kind of help are y'all? All right. The reason why you're getting two values is because this is a quadratic, right? And a quadratic has their y values are going to repeat, except at the vertex, correct? However, you have to use terms of this problem. In terms of this problem, are we looking at 5? Is 5 even on our chart, the length of the fish? No, we're not. So we would be using the value that makes the most sense for our problem, which would be 35. So for 30, the value that we get is roughly 35. Make sense? Yes. You can't just do it on the table because the table is an estimation, right? And it's saying use a regression model that you created to fill in those gaps. So it wants you to use a regression model. And so this is using the regression model to fill in those gaps. So when y equals 30, this is where I'm at. Okay. So when you're given the y, you're plugging y equals in and finding that point of intersection. Does that make sense? Okay. So for this case, we ended up with, I couldn't see the number. I'm going to put it here so I can say, so I can see it a little better, hopefully. Control C. All right, so we have 35.37, 35.3. I'm just going to leave it at 0.3. So on here, my first blank that I have, I know that I have 35.3 when it's 30. Okay, now I want you to do the same thing to find our other missing blank. Our other missing blank was at y equals 41. Okay, so what would be the input that gives me 41? So doing what we just did, and if you need help, let me know. But doing what we just did, what would I need to do to find the missing for 41? Oh, that one. Goes into that. Into that. My phone was in my lunchbox. And it only came out for emergencies. Yes. Yes. You know why it was in my lunchbox? Because I left my lunchbox and my phone at home because I put my phone in my lunchbox. And I was rushing out the house. So I can get it. If it was just my lunch, it would have been fine. My phone in my lunch. I'm here all day in just in case. What are we going to come back? All right, are we good? No one needed me for 41. All right, let's talk about it. So when you did y equals 41, all you have to do is come in here, change that 31 to a 41. And again, using your math sense, I'm not using the left side, right? So going to the right side, on the right side, we have the value. This value, when I round, the 5 is going to round the 9 to 10. The 10 is going to round the 8 to a 9. So the value is approximately at 39. Yes. Yes. So if it's higher, so like now that I'm at 41, I can move this up and down. And I can change the value to be whatever I want it to be. It should automatically come when you type in y equals 41. I can come and look, but it should have just automatically been y equals 41 and it could have came. And then you can just go up and down. Okay. All right. So if I had higher values, let's say I had 100. Now that I'm at 100, I can now say, okay, I'm looking for any point along that line, that point. Where is it happening? Does that make sense? Okay. All right. So that is the end of our C in that sense. So we ended up with 39 and 39 is our 45. Okay. Huh? 41. Oh, thank you. So normally, we may not get this lucky with a pattern. So obviously with this pattern, 39 fell right in place, right? But the regression models for when it doesn't fall in place. So here we have, this is one of the largest yellowfish tunas ever caught, had a length of 109 inches and weighed 480 pounds. How accurately would your regression equation from part B have predicted the weight of a tuna based on its length of 109? If there is a difference between the actual weight and the predicted weight, what might be a reason for the difference? So you see how they gave us the value of 109 and 480? So those are values that we can add to our initial table, okay? And from there, because we're running our regression and we're looking at residuals, it's going to tell us the difference between the two. So right here, I'm going to go up to our initial table and I'm going to add in what it gave to me. It said that the fish was how long? 109, and it weighed how much? 480. So this is your actual data, right? Based on this, it's going to tell you what your error would be between the fish and the actual, the predicted and the actual. Remember, your residual is your actual minus your predicted, correct? And this is what your residual is calculating. It calculates for you what is your actual minus your predicted. So based on this value, it says how much difference would there be, right? So even if you're not sure, if I came right here and I typed in 109, into the thing, it tells you how accurate, this is our R squared, how accurately or how much different this is going to be, how off it's going to be, if it's an overestimate, if it's an underestimate. Remember, because this is negative, we knew that it was going to be an overestimate on our part, right? A negative residual means you have an overestimate. A positive residual means you have a underestimate. I know we haven't talked about that in a few weeks, but that's where that value would come from. Okay. So when you look here, we are technically, according to this, the fish should have been how big? 717, but their fish was 480. So that makes sense that it was a no, sorry, I said that backwards. Underestimate. No, overestimate, because estimate is 717. I said it right. Negative is over. Negative is over. Negative is over. Negative is over. There we go. I've said 3 times. My brain will make sure that I'm not crazy. So negative means it was overestimate because your regression is your estimate. Your regression is your estimate. You're given, these are your facts. Does that make sense? This is what someone recorded. This is the data. This is what it is. And then this is your estimate. So that's what it means on the last question. It wants you to find the difference between the two, the actual weight and the predicted, and what might be the reason for the difference. Why do you think it's such a drastic difference between the two? Is what it's asking you. So you notice how even what did my graph even do? When I added that value, it shifted, right? It caused my whole regression model to throw off. So we're going to take that back out and we're going to just once we take that data out, notice it did what? It still stayed the same on our table, right? Because I'm following this value here. And unless I make alterations to this value, it's going to stay the same. All right. So 717 minus 480 is what, roughly? I'm not going to do it roughly. I'm just going to type in the calculator. Silly goose. So copy. Remember, residual equals your R. Your R equals your actual minus your predicted. Your actual minus your predicted. So our actual is 480 minus our predicted. And so it is an overestimate of 237.6. We'll go with that, right? So on here, we would write regression gives an overestimate of, what was it, 700? I said, what was our overestimate amount? 770? 17 of 717, which is negative 200. Since you guys aren't talking to me, 237.6. The negative's not necessary. More than actual. Okay. And that's what you're supposed to be able to do. So now putting it all together, coming to the end of this unit, at this point, from us going from learning about linear, quadratic, exponential, identifying all the different parts in our Freyer model, then from our Freyer model, talking about how we can relate it to Algebra 1 with our linear equations, right? All the different ways of identifying the linear, talking about all of our y-intercepts, and talking about the table patterns. All of that comes and accumulates to this end. So this is the very last thing that we had to learn for Unit 1A, okay? This piece is just literally tying it all together. So as your agenda said today, we completed all the notes for Part C. You have an exit ticket to do, 1A.7 exit ticket if you haven't done it thus far. And then you have a 1A performance task. So this is our practice performance task, which means that doesn't count as a test like our actual performance task. So it counts as like basically a quiz, essentially. But let me go to it. But for your performance task, you are allowed to work in your group, help each other. So on here, we are now at the exit ticket. So you're going to click on your exit ticket. On your 1A.7 exit ticket, you are essentially doing what we've been doing, right? The task is, can you do it on your own? All right. Can you do it on your own? Can you get through the problem? Okay. After you have that, you do have the practice problems. And this is going over all 3 parts of the notes. You do have 3 attempts on it, and it does take the highest. And then many times did I post it? Okay, I'll fix that in a second. It should be the one thing. I think I posted it twice and called it something different each time. So smart. All right, and then next is the performance task. So on your end, the performance task should open up as a fillable PDF. Does that make sense? So on your end, but what you need for are these data so that you're not having to type in all of the numbers. Your Desmos is pre-inputted for you. Does that make sense? So you're not typing, the values are already put in for you. Okay. So when you get here to your performance task, the values are already put into Desmos for you. Your job is to run through the steps of finding the regression. Make sense? Okay. Um, and then I think that's it. So that's what we're doing for the remainder of the period. You will have time after your test on Wednesday to finish your performance task, but you will need to work on your 1A.7 assignment for homework. Okay. Um, Oh, note card. So everyone in the basket, there should be a note card that you can grab out of there. On that note card, I'm going to strongly encourage you, if you're struggling with remembering the steps, to maybe consider writing those steps out. You are allowed to make a standard size note card for your test, front and back. If you don't have the note card come Wednesday, then it is what it is. And you're going to take the test with the knowledge in your brain, right? But as you're working on your review, as you're working on your notes, as you're organizing your interactive notebook, you can use that information to compile your note card. Okay. Um, anything we've learned from here to now is free game. That's all stuff that is supposed to be on that test. Okay. On that checkpoint. So, questions, comments, concerns about what you're going to be doing for the rest of the day, rest of the period? All right. Awesome. And that is all I have for you. And go be productive.